Welcome to Chapter 7.7, Comparing Functions. So there is no vocabulary for this lesson, but just keep in mind that functions can be graphs, they can be tables, or they can be equations. Every function has one of each. So let's jump into the first example. Example 1 asks, which function has the greater rate of change? So here I see a table and I see an equation. I'm going to start with the equation simply because it's easier, because the rate of change or the slope, that m, is given to me. So for the equation, my slope is equal to 4. So in the table, I'm going to pick any 2 points in the table. I'm going to choose this one, 1, 5, and I'm going to choose this one, 4, 14. Now, it doesn't matter. It will work with any 2 points. So remember that rate of change or slope is rise over run, or the change in y over the change in x. So I'm going to make this point A and this point B. So I'm going to do B minus A. So 14 minus 5, change in my y values, over 4 minus 1, change in my x values. 14 minus 5 is 9, 4 minus 1 is 3. I can simplify this to 3. So I have a rate of change of 3, a slope of 4, which has the greater rate of change. The equation has the greater rate of change. So let's apply this concept of rate of change to real life in example 2. So a key is trying to decide what baseball camp to attend. For each camp, the relationship between number of days and total cost is linear. Which camp has the greater initial cost? So if we take a look at Bright Future Baseball Camp, we see that it costs $18 per day, and there's an $89 registration fee. So the total cost is equal to the $89 registration fee plus $18 per day. We'll use D for day. So $89 is my initial cost. It's what I have to pay before I attend even a single solitary day. Home Run Baseball Camp, however, sets it up a little bit differently. They say 2 days costs $121 and 7 days costs $236. Well, that doesn't tell me what the registration fee is, so I'm going to have to figure it out. So if I think of this in a table, the day, D, is my independent variable, and the cost, C, is my dependent variable. The cost depends on how many days I go. So 2 days is $121, and 7 days is $236. Now that I have 2 points, I can use the, I can find the slope by finding 236 minus 121, the change in my cost, over 7 minus 2, the change in the number of days. So I see that that is 115 over 5. And if I simplify that, I get 23. So this tells me my slope, which is $23 per day. So I'm going to take this, y equals mx plus b. Well, I know my slope. I just found it. That's what this is, my slope. How much is my change per day? It cost me $23 per day. So $23 per day. And I'm going to pick one of these points and I'm going to plug it in. So the total cost, $121, equals $23 per day times 2 days plus B. That's my registration fee, the initial cost. And I'm simply going to solve. So let me move this. So 121 equals 26 plus B. That's a B, really. Subtract 26 from both sides. And B equals 75. So 75 is my initial cost for Home Run Baseball Camp. $89 is my initial cost for Bright Future Baseball Camp. So which has the greater initial cost? Bright Futures Baseball Camp has the greater initial cost. So one side was very easy. They gave it to us. The other side, we have to find the slope, plug the slope in, and solve for B, the initial cost. Example 3, same concept now applied to money. Jack and Manny each have a savings account. The graph at the left represents, or in this case, the right, represents Jack's account. Manny deposited $500 and withdrew $20 each even-numbered day for 30 days. Compare the functions. So let's start with Jack. Notice I've created a table here. When I'm comparing functions, I want to know, is my function increasing or decreasing? So if I look at Jack, this is called a step function. We haven't done much with step functions yet, so let's talk a little bit about it. I see here at day 0, there's a closed circle at $100, meaning he deposited $100. That $100 stayed in the account until day 6, which has an open circle, and then it shoots straight up to here to a closed circle at $200. That means on day 6, Jack deposited an additional $100. And that 100, now he has a total of $200 that stayed in the account until day 12. On day 12, I see it drops down to $150. So he must have withdrawn $50 from his account on day 12. So that $150 stays in his account until day 15, where all of a sudden he deposits another $100 for a total of $250. 6 days later, on day 21, he deposits $50 for $300. And on day 27, he deposits another $100 for a total of $400, which he still has on day 30. So I see overall, Jack's account has an overall increase. There is one little decrease right here, but overall, it's increasing. Is this continuous or discrete? Well, it's definitely not continuous, so we'll call it discrete or not continuous. Maximum and minimum. What is the smallest and greatest amount of money that he had? Well, I see at the end of 30 days, he had $400 in his account. But he started on day 0 with just $100 in his account. So that's Jack's account. Let's take a look at Manny's. So the problem said Manny deposited $500 and withdrew $20 each even numbered day for 30 days. Okay, well, withdrawing money means that my money is coming out. So the amount of my account is decreasing. It's decreasing by $20 every other day, so it's not continuously losing money. So this is also discrete or not continuous. He deposited $500 and then he withdrew money. So his maximum is $500. Let's see, if he withdrew $20 a day and he did that every other day for 30 days, that would be 15 days, which is a total of $300 that he withdrew. So his minimum is that $500 he started with minus the $300. So he ended the month with $200 as his minimum. So when you're asked to compare the functions, these are the things I'm looking for. The increase and decrease, is it continuous or not? And what is the maximum and what is the minimum of each account, assuming that you have enough information. Example 4, bicycle racing. Arama and Francisco trained for bicycle races. The graph to the left represents the distance Arama traveled during today's training session. Franco's distance is given by the function d equals 18.5 t, where d represents distance and in miles and t represents time in hours. Who traveled at a faster rate? So rate of change. This is also a unit rate. How far did they travel in 1 hour? Which is also the slope of the line. So Francisco, his equation was d equals 18.5 t. So if t is 1 hour, he would travel 18.5 miles. So his rate is 18.5 miles per hour. Our Aramana's distance gets a little bit more complicated. This is given to us in a graph. So we see my time is counting by hours, but it's skipping lines. So each individual line represents half an hour. So if I create a table for time and distance, I see that at half an hour, she has traveled 10 miles right here. And up here at 2.5 hours, oh, I didn't write half. I wrote 1/5. Let me change that. At 2.5 hours, she has ridden 50 miles. So I need to find the slope of that line. So again, rise over run. So 50 minus 10, changing my y values, over 2.5 minus 0.5 equals 40 over 2. 40 over 2 equals 20. So her rate of change was 20 miles per hour. So who traveled at a faster rate? Aramana did. Because her unit rate, her slope, her rate of change was 1.5 miles per hour faster than Francisco's.